So far we've visualized a fair few of our images. You could keep going if you wanted to get a better idea of them, but we're going to leave that for now. We've seen that when we read our images in, they're actually in the form of a giant array, or a tensor, after we've turned it into a tensor with TensorFlow, of different pixel values. And these are, because there's 3 color channels, red, green, and blue, are between 0 and 255, which means if this was red, green, blue, and this was 0, and this was 0, and this was 255, this individual pixel here would be a very blue pixel. So we come down, if we wanted to check the shape of our image, so view the image shape, go img.shape. We get here 512 width, 512 height, and 3 different color channels for red, green, and blue. So this is returns width, height, color channels. Now, we could pass this because this is a numerical representation of our image data to a neural network. However, in a previous section, we've discussed it's often important to pre-process our numerical data to get it ready for a neural network. And what was one of the most important steps when pre-processing our numerical data before passing it to a neural network? If you're not sure, that's completely fine. We're going to go back over it. To jog our memories, let's return back to the keynote. We'll go back to the previous slide, jump straight to the end. So we've got our computer vision inputs and outputs. There's a lot going on in this slide, but essentially what we've got is an image. Let's focus on one. Its width is 224, its height is 224, and it's got 3 color channels. We pass it in a numerical encoding form with normalized pixel values. Or scaled. Another word for normalized is scaled. And that's our inputs to a neural network or machine learning algorithm. So we've kind of given it away there, but let's go back to our modeling with TensorFlow. And if we go right to the end, what we're doing now is getting our data ready. So turning it into tensors. Have we turned all our data into numbers? Well, we've got one way to do that with our images. So neural networks can't handle images, they need to be numerical. Make sure all of your tensors are the right shape. Well, we haven't quite jumped to that yet, so we're going to skip ahead to scaling features. So normalize or standardize. Neural networks tend to prefer normalization, which is getting all of the values in our input tensor between 0 and 1. Again, another word for normalization is scaling. So how might we do that? So get all the pixel values between 0 and 1. We can just do image.divide by 225. And I do the dot here, so it turns it into a float. And there we go. All of the pixel values are now between 0 and 1. How easy was that? Now, you might be thinking, Daniel, if we had to do that for every image, that would be extremely tedious. And you're completely right. Right now, our viewRandomImage function only views one image at a time. It returns one image. And then if we wanted to pre-process it to pass it to a neural network, we'd have to write some code to pre-process them all and get the values between 0 and 1. But it's going to take a long time. So you might have guessed, TensorFlow actually provides some functionality to do all of this for us. So that's what we're going to have a look at in the next video. We're going to actually go end to end. If we come back to the keynote, we're going to build the architecture of a CNN. So if we have a look, we go through all of these steps. We've got the input layer, the convolutional layer, the hidden activation, the pooling layer, the fully connected layer, the output activation. Whew, this is tiny VGG. So that's what we'll go through in the next video. We'll look at an end-to-end example to both read in data, prepare it for a convolutional neural network. We'll also have a go at coding these layers for the first time. We'll compile our model just like we have before, and then we'll fit it to the data. So I'll see you then.